Dear all, welcome to Om Learning Classes. First of all, I am very thankful to one and all for showing your interest in Om Learning Classes. So in this lecture, we are going to learn Frequency Modulation Index. That is basic parameter of frequency modulated wave. So as per the definition of frequency modulation scheme, what we have, it is the type of angle modulation. As per the type of angular modulation, we have FM frequency modulation as well as phase modulation. So in this lecture, we are considering the basic parameter or basic fundamental of FM. So the FM is the type of angle modulation in which the instantaneous frequency I mentioned, that is Fi, with the consideration of angular frequency, instantaneous angular frequency omega I of the carrier signal is proportional to instantaneous amplitude variation of modulating signal while keeping the amplitude of the carrier signal constant. So in this we have three things. The first fundamental thing, we have to calculate the instantaneous frequency of the carrier signal for frequency modulated signal. The second factor, we have that instantaneous frequency is calculated from frequency of the carrier signal with the instantaneous amplitude variation of amplitude of modulating signal. And the third fundamental, we have that the amplitude of the carrier signal remains constant. So based upon these three fundamental, we have the complete definition of frequency modulation. So for the frequency modulation index, and by considering the single tone modulating signal, the frequency modulation index MF is defined as the ratio of peak frequency deviation in the frequency modulated signal to the modulating frequency of the baseband signal. So first we have the peak frequency deviation and another we have the modulating frequency, and by utilizing both the parameter we calculate the modulation index of frequency modulated signal. Very important, in this the ratio at the denominator part we have the modulating frequency. So by considering both the factors and by their ratio, we have the parameter that is frequency modulation index. So as per the basic equation of delta F, that delta F is equivalent to Kf mt and their maximum value. Here we consider if the mt is our am cos 2 pi f mt, then the amplitude is considered and that is Kf am to the frequency of the modulating signal. So this is our unmodulated carrier signal Fc. This is the unmodulated carrier frequency, and by providing a positive frequency deviation, we get the frequency, maximum frequency in the frequency modulated wave. Similarly, if the Fc is considered with negative frequency deviation, then we found the minimum frequency in the frequency modulated wave, and by considering both F maximum and F minimum, that becomes the carrier swing that is equivalent to 2 delta F. So we can say that 2 delta F is equal to F maximum minus F minimum. So we can say that the F maximum minus F minimum, that is equivalent to 2 delta F, which is our carrier swing. So by utilizing this fundamental, we can define the delta F with respect to this formula, that is F maximum minus F minimum divided by 2, that is your frequency deviation, and to Fm is as per the part of MF. So we are resultant with another formula in terms of maximum frequency of the frequency modulated signal and minimum frequency of the frequency modulated wave, and with consideration of modulating frequency. So this is F maximum minus F minimum divided by 2F. This formula is very important. If any numerical or when we perform the experiment of frequency modulated wave, then we have the wave, and by observing the wave, FM wave, we can find out the modulation index. Then this mathematical formula can be utilized, because in the waveform we can easily find out the F maximum, F minimum and FM is also given. So by utilizing all these three factors, we can calculate the MF. Because in this formula there is requirement of KF, and as if the waveform is given, then KF is not defined, and if KF is defined, then there is no requirement of waveform. So in this point we have both the formula of modulation index. The first formula is related with the delta by FM, and in another formula we defines the delta F in terms of maximum frequency and minimum frequency of the frequency modulated wave, and by considering the modulating frequency. So it is very important as per the concern of your experimental behavior as well as theoretical behavior. So if we observe the important point related with the modulation index of FM wave, then we can find there is no practical limit of the maximum value of MF. Very important, there is no practical limit, because if we compare this with respect to modulation index of amplitude wave, then what we have, then for the case of under modulation and critical modulation, the MF should be equivalent to or less than 1, and if it is greater than 1, then over modulation can be takes place. So, and in over modulation case we can't utilize the envelope detector. So in amplitude wave we have the practical limit of modulation index, but in this case there is no practical limit on the maximum value of MF. The value of MF is often greater than 1, and for practical purpose we generally utilize the frequency modulation index 5 while considering the band 88 to 108 megahertz. Another factor we have that increasing the amplitude or frequency of the modulating signal does not result in the over modulation or distortion in FM. Very important point. This is very important point, and this is the key feature of FM over air. Means if we increase the amplitude of the modulating signal or frequency of the modulating signal, then it will not result in the over modulation or distortion in MF. But if we do it, then we have the another increment in the transmission bandwidth. After that, in the frequency modulation index, what we have the practical example by considering the commercial FM broadcast standards. If we consider this frequency modulation broadcast standard, then the band is 88 to 108 megahertz. We generally utilize the FM in our mobile phones, and if we observe their frequency band, then it is 88 to 108 megahertz. For example, the 93.5 FM. The 93.5 FM is their center carrier frequency on which that signal is resulted. So it is 93.5 megahertz. So this is the operating frequency range. After that, as per this operating frequency range, we have number of channels that is equal to 100 by considering the channel bandwidth and guard bandwidth 200 kilohertz. So 200 kilohertz is the single channel bandwidth, and it is also bandwidth of guard band between two subsequent channels. So by considering this, we are resulted with 100 number of channel for this frequency modulated spectrum. And if you operate with the modulating signal frequency, then it is 50 to 15 kilohertz, 50 hertz to 15 kilohertz. And very important point for which I will consider this example, that the frequency modulation index as MF is, we have considered for this spectrum that is equivalent to, it is fixed and it is 5, while considering the frequency deviation 75 kilohertz. From this we can find out the 75 kilohertz divided by maximum modulating frequency 15 kilohertz. So 75 kilohertz divided by 15 kilohertz, we are resulted with the MF that is 5. And we have another important thing, that is signal to noise and distortion ratio, that is 30 dB and 60 deviation with the 1 kilohertz tone. So these are the practical fundamentals related with commercial FM broadcast standard. So with this point, we complete the session of Frequency Modulation Index MF with their example and practical concern. In next lecture, we are going to learn another basic fundamental of FM, that is frequency deviation factor and percentage modulation. Thank you very much one and all for your precious time. Stay healthy and enjoy smart learning. Thank you very much.